Welcome to Ask and Learn.
Okay, here we have a function y equals x cubed plus 3x squared, and we want to graph it. We know because it's cubic, it probably has some general shape like this, but let's go ahead and figure it out more specifically. I'm going to go ahead and find the zeros first. I'm going to notice that x squared is in common, leaving behind x plus 3. So we know that we have zeros whenever x equals 0 or x equals minus 3. So I'll go ahead and do those right away, and that will give us some help with the graphing. And I can certainly just keep plotting points, and I would be able to get the general shape of the graph. But let's use some derivatives. So let's keep going and find the first derivative. First derivative will be by power rule, 3x squared plus 6x. I can factor out a 3x, giving me x plus 2. And if I set that equal to 0, we find out that we have critical points at x equals 0 and x equals minus 2. And so I'm going to go ahead and make a sign chart and keep it running so I can see what's happening. Okay, so at 0 and at, let's put the 0 on the right since we need room for the minus 2. Okay, so we will put 0 here, minus 2 here, that's our x. And our f prime of x is 0 at both of these locations. Let's go ahead and plug in values to find out whether f prime of x is positive or negative in the different intervals. If I plug in something bigger than 0, like 1, I'll definitely get a positive. If I plug in minus 1, I will get a negative. If I plug in minus 3, I will get double negative, so that's a positive. All right, good. So I'm increasing, decreasing, increasing. All right, now let's take a look at our next derivative. Let's do y double prime. That'll be 6x plus 6 by power rule. So pull out the 6 and I get x plus 1. And that equals 0 when x equals minus 1. So let's plot that on our chart. Minus 1, that's the 0 for f double prime. And let's again do the signs. When you're bigger than minus 1, you definitely get a positive. So you get a positive, positive, and when you're less than negative 1, then you get negative. And then this is how I really love doing the sign chart, because this is how I can know the kind of general shape. So I have less than minus 2, I'm increasing concave down. So I've got this shape. And between minus 2 and minus 1, I'm decreasing because I have a negative first derivative, but I'm concave down, so decreasing concave down. So that would be like this. Then minus 1 is 0, I'm decreasing concave up. And then at the last bit, I'm increasing concave up. So I get my general shapes, which is cool. And all right, so let's find also like max and min. We know max occurs when f prime goes from plus to minus, so this will be a max point, and this will be a min point. And then here's the point of inflection, because that's when f double prime changes sign, point of inflection. Okay, so let's get the actual points. The max occurs at minus 2. Let's plug it back into the original. So it's 4 times 1, so 4. The min occurs at x equals 0. So when we plug that in, we get 0. Good to know. Then our point of inflection occurs at minus 1. Let's plug that in. And that gives us 1 minus 3, so minus 2. So now we have all sorts of points to plug in. Let me double check I did that right. If I plug in minus 1, I get minus 1, a plus 3. So that's actually positive 2. I was looking at the wrong thing. Okay, so let's plug in those points and we'll be able to finish drawing our graph. Okay, so minus 2, 4. We have a point up here. We have a point at a point of inflection at minus 1, 2. So that's the point of inflection. So basically we know that we have this shape, then it switches to concave up, because we have, so far we've done that shape and that shape. Now we're concave up decreasing, and then we're going to be concave up increasing as we get past the min. So let's just plug in 1 point on the right side. How about plugging in 1? We plug in 1, we get 4. So then that would be up here. And we have, I think that's sufficient. We have drawn our graph. No horizontal asymptotes, no vertical asymptotes, just a nice, wonderful cubic function. So anyway, that's a lot of fun. Hopefully it helped. Have a great day.